Hello and welcome back to my latest episode. Today we will take a look at the new ESPKnack in preparation for this month's exciting Kickstarter launch. Good to see you back in my electronics lab and welcome, especially for those of you that recently subscribed and are now sitting in the front row. My name is Dave Williams. And in this episode, I will explore the new ESPKnack project and outline the many features in this flexible and compact board. Guess the question could be, what is ESPKnack? Well, ESPKnack is a very flexible ESP32-C6 based LoRa board and has been designed to be compact whilst offering a range of features, including galvanically isolated inputs and outputs. Before we delve into the board, as an overview, the ESPKnack is one of those electronic Swiss Army knives, in that it contains a number of dedicated devices which provide reliable interfaces to the outside world. First off, we have the powerful ESP32-C6, which includes Wi-Fi, Bluetooth, Zigbee and Thread. This in turn connects to the popular SX1262 based LoRa transceiver, which may be used anywhere between 850 MHz right through to 930 MHz, so covering the LoRa and LoRaWAN bands used throughout the world. In addition, I've included the popular accurate real-time clock, the DS3231SN, which has an optional battery backup, also a 64K EEPROM for local settings and logs, plus a TMP102 digital temperature sensor. Inputs to the ESPKnack include the industry standard RS485, which is also galvanically isolated. A 4 to 20 mA current loop interface is included that could be connected to a range of external sensors, for example. The core ADC is the popular 16-bit ADS1115, which is used for the accurate current loop monitoring, and also an ADC single-ended and differential inputs. Two opto-isolator inputs allow for single-ended and again differential signal digital monitoring. Outputs include two 10-amp relays. These could be up to 30 volts DC or 250 volt AC, which provide normally closed or open dry contacts. In addition, a digital GPIO and PWM FET output is provided. This could be used perhaps to control external devices. Plus, an opto-isolated digital open collector output is included. The culmination of these flexible inputs and outputs should allow for many different projects and installations. As with all my boards, the ESPKnack includes the standard UART interface for easy flashing and monitoring. An expansion port allows for interfacing to the optional panel display, and a second SPI port has been included for the connection to the microSD. To allow for a range of installations and DC power options, the ESPKnack board may be powered from the USB 5 volts or also through the high voltage DC input, which allows the board to be powered from 5 volts right through to 60 volts DC with a maximum of 75 volts. This voltage flexibility means the board could be solar or lithium battery powered, for example. An on-board separate 3v3 switch mode power supply provides the power to the board's devices, with an additional 24 volt switch mode power supply output for power to external devices. Using the provided expansion interface, you may plug in the optional display board, which has both tactile buttons and LEDs. Plus it includes an additional Type-C interface and a microSD card slot. The boards are designed to fit into a nice optional DIN enclosure, allowing easy access to all of the connections. And finally, should you wish, a complete ESPKnack kit is available, which contains all the magic ingredients to fulfill the most interesting of projects. Here is the ESPKnack on the bench, powered up, ready for example testing. It would be good though to have a look around the various interfaces before we delve further. First is the industry-established electrical standard RS485 port. RS485 uses two-wire or often twisted pair differential signaling, where the current flows from the driver through the line and across a typical 120 ohm termination resistor. It can also have up to 32 connected slave devices. In some special configurations, this could even in theory go up to 128 devices. The real positive from RS485 is the robustness, noise rejection from external electric or magnetic EMI, cable lengths, and data rates. The RS485 on the ESP Knack is fully isolated from ground. Cable lengths could be up to 1200 meters or 4000 feet. The RS485 interface on the ESP Knack can be used as a master or a slave device, and can also be used for DMX lighting and sound control. An isolated ground is provided as a return path, such as when using shielded cables or DMX control. The 4 to 20 mA current loop interface allows for an accurate current monitor, which linearly converts the current to a voltage and then is fed into the ADC. This current loop can be used as a single interface for a range of available sensors. A feature of the 4 to 20 mA current loop is fault monitoring by easily detecting an open circuit. Next is an input to the ESP GP2. This could be also used as the output if required. We then look at the ADC inputs. These two inputs go through a passive circuit to allow the voltage monitoring of either 0 to 3.3 volts or 0 to 60 volts, a maximum of 75. Selection is made using the relative high voltage jumper on the board. The opto interface is an isolated or differential digital input that goes into an opto isolator. Then we have a single-ended digital input that goes to another opto isolator with reference to ground. At the bottom, to allow for external devices to be powered and reference to the ESP Knack, we have a VCC out, which has a selectable 3.3 volts or 5 volt option. The ESP Knack has an onboard high voltage switch mode power supply, which facilitates DC input from 4.5 volts right through to 60 volts DC, with a maximum of 75 volts. This allows the board to be powered from a wide range of DC supplies, batteries, solar, wind, etc. Moving to the opposite side of the interfaces, the ESP Knack has a dedicated 24 volt boost switch mode power supply in order to provide a stable 24 volts output, even if the board has 5 volts supplied. This can be enabled via the jumper on the board. A separate fixed constant 5 volts output is also provided. Two relays provide independent and fully isolated, normally open and closed dry contacts. Each relay can support up to 10 amps at 30 volts DC and 10 amps at 250 volt AC. Galvanic isolation is provided for safety on the PCB for both relays. Output from the onboard GPIO expander P5 is next. This could also be an input if needed. We have an output from the ESP GP15. This could also be an input if needed. Typically, this GPIO is a digital out or PWM out. The LoRa transceiver has a TX or transmitter enable, and this is outputs to the interface. This may be used for external LoRa TX monitoring, such as for RF power amplifiers. Moving up, we have an output from the ESP GP15 via FET. This interface is digital out only, or PWM out. And finally, we have the opto isolated output, which is an open transistor collector and emitter to the interface. As you can see, the ESP Knack is a very capable board with a lot of flexibility for both development uses, home and commercial projects. The board shown here is currently connected to both my PC via USB-C and also an external power supply. You can safely have both connected as all supplies are diode protected. Here we have a 4 to 20 mA current loop generator set to a maximum of 20 mA with a current control in series looped back into the ESP Knack. This allows me to test the current loop interface and read the voltages on the serial monitor. This is the output of the ADC, showing the 4 inputs with one, ADC1, being on the current loop and me varying the current, and it's reflecting in the display. Okay, now let's turn off the current loop and move to the GPIO. In addition to the ESP32-C6 GPIO, ancillary GPIOs on the ESPKnack, such as the relays and opto-outs, are controlled by a TCA6408, which is an 8-port GPIO expander. So I'm just flashing some test code to the board now, just to show that the outputs are being controlled, and you should see the relays toggling as an example. So just writing data at the moment, and there we are. Obviously each relay is independent, as is the opto-outs. And moving this board out of the way, it's come through to the display. So there's a little 12-way connector on here. In fact, the production version has two. It's a 6-way and a 12-way. So we can plug in the connector to there, and then that gives us connection to the little display board, which we can have a 0.96 display connected, plugged in, or we can have the larger 1.3. Let's plug it into there. There we are. So we have two options for display size as needed. In fact, the production version has also got the micro SD on the rear of the board. And then we look at the. If we actually unplug that one for a moment, and then we look into the enclosure. So the idea is that the board fits in there nicely, and the board fits into there, plugs in, and then we can have our display plugged in like that, and then we have a nice neat, and that would be effectively the ESPKnack and the display board connected up. And there is a cover that can be attached to both sides, and obviously breakouts of the connections where needed. Okay, so and this is the cover that can go on top of the display and then just clips in to give protection. Let's just put that one on the other side like that for completeness. We'll just clip that in. Good, thank you. And finally, please do not forget to kindly give me a thumbs up, as this will be much appreciated, and even the subscribe button, to ensure that you are also in the front row of my future videos. As always, I really do appreciate the support and feedback given back to me, and in turn passed on to other STEM makers and ambassadors around the world. Many thanks for watching, and look forward to speaking to you in the next video. Take care. Bye-bye.